Today we're doing the Realistic 3000 base station, and this is from my original file from 1983, which is when it came out. It was the only base station CB radio that Tandy's did in the UK, and it's disappointing because on the American market they had a number of base stations. Because of its lack of features, it didn't score much on our system, 74%, but its performance was there. We got ours in a clearance sale at $69.95, and they were $149.95 originally. What you'll notice from the photo there is people who know about CB radios will notice it's the same innards as the TRC3002 mobile. So you've got the two transformers there, we've got the two transformers there, you've got the audio IC and two capacitors there, you've got the audio IC and two capacitors there. But it's the same chassis as the TRC3002. And I say that because for some obscure reason the service manual is missing from the file. Now these Tandy service manuals are $16.99. They're a lot of money to throw out in the hope that you were going to get some repairs in and make something on it, and I've probably had two in over the 38 years. Now whether or not this is our original one, because I know, as I said, we did buy one, or whether or not this is one that's just got bought along the way, I have no idea. So you've got the extension speaker on the back, high-low power on the back, aerial sockets of course on the back, headphone socket, microphone socket, which is the standard locking 5-pin DIN that Tandy's use. And what's really unusual, and it's really a throwback to the American AM days, we have a mod light, not a TX light, but a mod light, and that does indeed flicker with the deviation on the FM system. So basic radio. But these were made for them by GRE, who are probably best known for scanners. So it's not a rubbish radio. So we'll open it up, and there's a lot of screws. Having opened it up, I know for sure it's not our original one. It's clearly one that's been bought in down the line, because all the screws are slotted when they should be Phillips Posidrive types. There should be a metal shield plate which sits there, and that's missing. There's insulating tape covering the fact that the black paint's missing over the front bit. Actually that looks fine. So I think we'll put the case through the company dishwasher. So you've got a shield plate at the bottom, and there should be one on the top as well. Probably going to be tempted to change the capacitors in the power supply, because I don't know how many hours this is, and the power supply is of the non-adjustable type, so we'll just monitor what that voltage is before proceeding. Now these are more complex to set up than some CB radios. I seem to recall we've got I don't know if we have to use a sweep generator, I can't remember, or whether it's something with a voltmeter, but I know there is something which is a bit more complex than some. Handily, the presets are labelled. For example, that says SM, so it's going to be signal meter, so that does help us. So it's a single crystal synthesizer, LC7137, the Sanyo's normal one used in a lot of sets. So you've got a single crystal oscillator for the frequency set. So that makes it easy, but I know there's something in the receiver. I haven't looked at one since the 90s. So this is a good candidate to do because it is an unknown, and I'll have to find a suitable mic, which will probably borrow off another Realistic. Because it's an unknown, I'll check the plug. There is a fuse in it, it's 5 amps, it should be 3 amps. We'll just check that the terminals are tight. It's one of the older types of plugs which doesn't have the shrouding around the pins. So if this was something we were selling, I would prefer to change the plug to one of the slightly safer, more modern ones. Just check they are tight. they are, and one with a 3 amp fuse. So that's that checked. So the mains go straight in to the on and off switch. So at least with this set, the mains is switched. And then I'm just looking at, without the service manual, and I'm not going to pull the wiring out. I don't know whether that's a primary fuse or a secondary fuse just there. So we do need to make sure the plug fuse is correct, and 5 amps will do for now, but I think we'll be tempted to change the plug with a 3 amp fuse later. So I'm going to plug this in, and first thing we're going to do is check how many volts that power supply is doing, and if it's under 12.8, then I'm going to point a finger at those capacitors. Okay, so I've got the meter in place, I've switched it on, it has lit up, and let's put the power supply on the output. Meter 13.2, that's absolutely fine, so I won't go down the capacitor avenue yet unless it hums. Right, was quite a, I seem to recall there's quite some setup procedure. I think what will help me is if I scan that diagram there, blow it up, and then colour it in my usual way, and that will help me, especially in the future if we see another one. Because having seen 2 in 38 years, I might see another one before I croak it. So I'll go and find a microphone and we'll go and blow that up. Okay, well I've done that, so that helps me, and I'll just go and collect the post. So I've done a microphone, I couldn't find a realistic one, so I've used one of our standard mics, put one of the high quality Rian, the gold plated pins, 5-pin DINs on. Now the original Tandy plastic ones have got a little latch on them, so of course these don't latch, but at least the quality's there. So we'll plug that in, and yeah, we've got TX. It's not supposed to be a faulty radio, this, and I've no doubt we've used it in the past, but nevertheless we're going to go through everything, and it's quite a complex procedure, and we start by having to remove resistor 94, one end of it. 94 should be that one there. So it's the thick 1 watt resistor. So we've got the output transistor, resistor 94 next to that choke, and we need to undo one end of that. And of course, to do that, we've got the fun of taking the shield plate off the bottom. So I'll do that. The service manual, first step 1, is they want you to set the frequency. Now, I don't want to set the frequency at this stage. It's much easier to do it when we're in transmit. So they want you to set it to 10.240461, and they want you to do that at the collector of transistor 3 with a 0.01 microfarad capacitor in series with your probe. But I don't want to do it that way, so I can't see any reason. It's not like there's delta tune like we got caught out with the low TX40 the other day. So step 2, they want you to set the VCO, which of course is what you'd expect. So it's transformer 8. So we'll pop the meter on. Now I can't remember whether this chassis is floating or not, so we'll just prove that. So I'll put one prod on the power supply positive and the other on the power supply negative, and I've got, just put that so we can all see it, and I've got 13.2. So put that to the chassis, and I haven't got 13.2. So I'll put the prod to one of the coils, and I've got 30.2, so it's a floating chassis. So I thought I'd better just check that. So what they want you to do is to connect your meter to pin 17 of IC1, which is a synthesizer. So pin 17. So is it, what are these, 10 pins if I remember? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, yeah. 11, 12, 13, 14, 15, 16, 17. So it's fourth from the other end. So if I put a crocodile clip lead between my negative probe and one of the cans, we should now have a voltage which is 3.95. Now they want you to be on transmit, and they want you to be on channel 40. So we'll get that shiny new microphone that I've just created and put somewhere. And transformer 8 is the one with the wax down there, and I'll get the green plastic trimming tool at the ready. So here we go. So I've got 5.67, so that's slightly high. Just try and get that in view a bit more. So whilst holding the probe on, this is, I need an extra hand, I tell you. We'll adjust that for 5. So that'll do nicely, 5.03. Now they want, what they want you to do is they want you to go into receive, and they want you to go to channel 1. And they want the VCO voltage to be between 3 and 4 volts on that same pin. And it's 3.22. So if it isn't if it isn't between 3 and 4, you'd have to do that procedure again. So as you can see, the VCO is very slightly out. It really wouldn't have mattered, but for the sake of the demonstration, that is the VCO now set. So T9 is what we're adjusting next, and for that we need a vacuum tube voltmeter, or what we're using is a FET voltmeter, and I'm trying to find the tool. So it is T9 is this one here. So we've done the VCO, which is T8, so we're moving on to T9. So what we need to do is to put a vacuum tube voltmeter onto the base of transistor 13. So there's transistor 13, and it's clearly labelled on the board emitter, collector, base, so it's the right hand leg. So I've got my meter connected to the chassis, to the earth, the negative through that coil, and this is funny because we're doing a Tandy base station and we're doing it with a Tandy meter. I've got a choice of 2 meters, so I thought I'll use the Tandy one. And the reason you can't use a digital one is you need to see a needle that moves, and it's no use getting the AVO out or something similar because the load of the meter drags down what we're trying to read, which is why it needs to be high sensitivity with electronics in it. So we're going to go onto that there, which we're now on, and we're going to be in transmit. Now I don't know what volts we're looking at, probably something quite low. So I've got it on the 3 volt range, so what we need to just do is adjust that for maximum. So we've got a broken core. Unbelievable, isn't it? So pause the video, unsolder the coil and see where. Now we were potentially in trouble here, because normally what we can do is to take the coil out of the radio and then remove it from the bottom, but the core doesn't go through to the bottom. So that plastic tool I found the other day, I've been able to put it in the damaged top. I still don't think we could have done this in the radio, and I've been able to spin it round, and it's just about at the top now, and I'm just hoping to be able to grab hold of it. If I can just get a grip on it. There we are, look at that. And what I'm hoping to be able to do is to put it in the other way around. There we go. So that's bodged that back together. Now we'll just have to solder it back in. And that's what happens when somebody tries to use a screwdriver instead of something which has a flat blade. It's supposed to be a ceramic tool or a plastic tool, but I don't find the plastic tool strong enough, and we've got a plastic tool there. We'll give it a go. So, and it's been transmit. And on the base of transistor 13, tell you what, that's a bit more healthy, isn't it? I'll go back to my phosphor bronze tool. We seem to be there anyway. And that's very fine adjustment. There's only just a small deflection. So next we're going to adjust transformer 10 with the same setup. Transformer 10 is this one. 9, 10. And this has got 2. So once again we're going to transmit, try and get that in the picture, put the probe on base of 13, very fine adjustments. So that is that done. I can disconnect that meter and switch it off. So the next thing they want you to do, we can check that you've got 370 millivolts on an RF voltmeter. Alternatively, we can reconnect resistor 94 and see whether it transmits. So we've got an RF voltmeter. It's that Russian thing that we use, but I think we'll just move onwards because it is a working set. Okay, so now we will move on to L5. So it's L5, L4, L3. So L5, L4, L3. T11's a harmonic trap for the second harmonic of 55.5825, and that really needs to be done into a spectrum analyzer. Now we've got a spectrum analyzer which I've shown you on the previous bench, a very simple one, basic, which we normally use, believe it or not, on Fidelity thousands, and which are very difficult to set up despite the poor performance. And I've lost the green tool again. Here it is. But I can't get the camera on that, I don't think. I'll have a think about that. There could be a way. So we're presenting. Oh, I'll just switch to camera 2. Okay, so there's camera 2. And now I'm competing with the BBC World Service News on the background music system because it's just gone 11 o'clock. So we're on L5 and we've got let's just see how many watts this radio is supposed to do. Although it's a 4-watt radio, it's supposed to be set to a maximum of 3.7, and 3.4 is acceptable before you need to do a repair, it says. So that's where it's supposed to be. So we're at about 2.8 at the moment. So we'll start with L5 and then we'll move on to L4. And then we'll go on to T11. Sorry, we won't. L3. Now that's a bit funny. It kind of we've got a kind of wrong core in there, and it's too thin. It's going all over the place. Yeah, right. I'll just have a look through my scrap chassis and just see whether we can find something that's going to fit in there a bit better from a similar position in some ancient heap of a radio. Well, I think myself very, very lucky. I had a scrap AM American illegal in this UK Realistic, and it'll be a GRE made one, and I've been able to pinch the core out of that coil, which is in an identical circuit position as the one I want for this job. So let's see what we get now. We make it worse, no my luck. So we'll get that in. So clearly that coil which was in, that core that was in the optimum position. I'll just touch that up and make sure. Now I'll just go through this time and time again, and I'll pause the camera while I do that. So when we start looking into it, we find it's got the wrong driver transistor. So we should have a 2086 on a heatsink, and as some of you'll know, that is a TO92 device. That is a 2314, not on a heatsink. Now then, where do I find a heatsink? I know where I find a 2086, but I don't know where I find a heatsink. Well, we kind of seem to be in luck today, because I found a scrap chassis for a Realistic 2002, and on this one, and it doesn't look like it's been fiddled with. We haven't got a 2086 driver, so we'll see what happens. So what I've overdone, that transistor which was in the scrap set didn't work, so what I've gone down the 2086 avenue, because that's what's specified. What I've done is to drill 2 extra holes in the heatsink there, and to tie wrap with lots of thermal compound the 2086 to the heatsink. Now, those of you familiar with CBs, where you see 2SC 2086s in use, they're always in free air. So I don't think it needs much heat dissipation, but we've done, I think, the best we can under the circumstances. It may be possible that I could order a TO92 case heatsink, but that would mean that we can't do this job today. Bear in mind, this isn't a customer's repair, it's just one of my stock radios that we're doing a demonstration on, but we do want it to do as close to 4 watts as we can. Okay, so having changed that and put it back together, we now find I can peak it to just under 3 watts, but that's still not acceptable. It needs to be that 3.4 watts because the manual says so. Had this been a Fidelity 1000, that would have been acceptable, but it isn't on this. So I'm going to take out the Mitsubishi 2SC 2166, and I think we'll compare the gain on that to a new one. Right, what we're going to do, we're going to move away from the transmitter because I want a part. I'm going to look for a closer tolerance resistor for use in a transmitter, and I'll show you what I'm doing when we get back to that. Unfortunately, I haven't got the access to the stores department at the moment, so we'll go on to the receiver. So we need to get back the we need to get back we go to channel 20, yeah, the VTVM, and we're looking at the base of transistor 3. So there's 1, 2, 3. It's the base of transistor 3. So transistor 3, base is clearly marked there. So we'll turn on. Okay. And what I'm now going to do is adjust T13. So T13 is the one on the double one on the left. Oh yes, so we're looking at that one, and what we're doing is aligning the second local oscillator. And I have to admit I can't see a thing on there. It's supposed to be about 35 millivolts. No, I can't see that. So in view of not getting what I'm looking for on the FET voltmeter, I'm simply going to adjust that with the synod meter. Of course, when they wrote this manual, they weren't expecting people to have nifty things like a synod meter. So I've done that. I'm satisfied that's set. So let's see what they want you to do next. Right, they're going to do 455. Right, we'll set that up. So what we've got is our IF signal generator that you've seen before. I'll just lose that camera for a moment. And let's just see if we can move to show that. So that's loosely coupled to the radio. And now what we're going to do is to adjust 4, 5 and 6 for maximum on that synod meter. 4, 5 and 6. Now they're suggesting that you are going to connect up a VTVM or a FET voltmeter as we were using, but there's just no point because we've got better equipment than what they are calling for. So there's the synod meter. So we're going to do 4, 5 and 6. Peak, peak, peak. There we go. So I can now take that away. And we should now be onto some of the more normal setup procedures. And that's transformers 1, 2 and 3, 1, 2 and 3. So put the signal generator on, make sure we're on frequency. And we are listening to 0.3 of a microvolt. So 1, 2 and 3. Tell you what, that brought it up. So we're trying to maintain about 4 decibels on the synod meter to make it easier. Wow, that brought it up too. And 3. That was already peak. So I'll just do those again. It can be interactive. You'll appreciate they just don't have this kind of time at the factory. They're going to twiddle it till it meets the minimum pass, and that's it. They're not going to go backwards and forwards like this. So there we are, that's done that. So we now go back on 4 and 7. Now I think 7 is detector, so I'm going to put a big signal on. We'll put the oscilloscope on, and I'll pause the video and reset camera 2 onto that. We'll turn the bench light off so we can see the maximum. Let's pop some volume on that. So let's see whether we... There we go. That's and they also say to go back onto 4 just to check. Now they want you to look for best symmetry, which I think we've just achieved. Okay, so let's see what's next. They want you to do the S meter next, so we'll put an S9 signal on there. We can now lose that, and it is VR5, which is that one, and it is labelled. And if I prop the set up, it's doing about +10. That's a bit dirty, so we'll just give it a quick spray. There we go, S9, that's spot on, so that was a bit high. And then they want you to do the squelch. So we'll turn the signal generator off, set squelch to threshold, switch the signal generator on, and see when squelch comes in. That's very harsh. That's 10 microvolts. So what we'll now do is back off VR1. So VR, oh, it says VR1. Sorry, VR1 is the one on the front panel, VR6, which is that one there. Okay, that's not happening. Is that dirty as well? Right, so that's moved it to the opposite way. Now we'll set that again. So turn the signal generator off, squelch to threshold, signal generator on. No, it's still 10, that's no good. That's 3 microvolts. And that's the most sensitive I can get it. So, how weak is that? So we'll turn the signal generator to the... we'll turn the squelch to full and see at what point we can open the squelch. And the answer is 3 volts. So considering we've now got that at minimum, yep, it looks like that is the best we can say. It's a bit harsh. I'll just go through that once again. Squelch to threshold. Signal generator on. Yep, 3 microvolts. Let's go on a finer scale. It's actually 2.5 it comes in at. So that's the best compromise. Okay, so that's set that. Now, whilst we're waiting for access to parts department, I can do the transmitter deviation because that won't alter. So what we're looking at is VR3. So VR3 is the back one, which is transmit deviation. It's the back preset. So we get our little oscillator. Going to transmit. In fact, I'll put the camera back on the test set meter so that we can see what this is together. It's a bit high, that at 2.8. So we'll pop that down. Let's put it down to about 2.1 and see what that is with the whistle test. Wallow. You know, it's a bit quiet, that, so we'll just go forwards a bit. 2.2 and a bit. Wallow. That's fine, that's now spot on. So that's covered deviation. We can't do the RF meter because we haven't got the RF where we want it yet. As it is, it's doing 3 watts. So if we were to set it at that, VR4, so we're there. So we're going to transmit. Again, we've got a dirty control. It's silver plated and they've tarnished over the years. So that now reads bang on 3. Now I'm going to check that, well, we're going to check low power does low power, but it's not going to mean anything. 0.35, so that's about where it should be for the power output. So we are done but we need to just go back on that transmitter as soon as I'm available to access that department here. So Mr. C will no doubt come back with the keys soon, and we'll have that sorted. So we've just got that transmitter to finish off, and apart from that, it's quite complicated to set up, as you can see. So you need the 455 IF signal generator, you need a VTVM or a FET voltmeter. Oh, we need to pop it on frequency. I'll tell you what, we'll do that right now, because that isn't going to alter. Now, they wanted you to do that first thing using a frequency counter, but we're using the test set. So I'll just set up camera 3 so that you can see that. There we are. So it's going to be the crystal trimmer, which is quite a nice quality one. We're going to transmit, and we'll see where it is. So it should be 2779125. Of course, it's dropped as they do with age. It's 79107. So let's see whether we can bring it up. Yep. So we'll leave it just slightly high at that, because it will drop off. So that's sorted that, and I'll stop the video and we'll come back on when I've got access to the parts. I've been talking to myself and I don't know now what I've said. So I'll repeat the last few minutes. So I came to the conclusion that resistor 90 down there, which should have been 47 ohms, was in fact 56 ohms. And when you look at the circuit diagram, it sets the gain effectively on the driver transistor for the RF. So I think we gained another 100 milliwatts there. As you know, we put the correct driver transistor in the 2086, and then I also changed the output transistor, which is the Mitsubishi 2166, and there was no change whatsoever in changing that. And so the one which was already in was fine. You could bring the output up by having a dozen output transistors, having them on an HFE meter, just seeing which is the best gain. This is a situation where the set has managed to just do 3.4 watts, which is the acceptable lower limit, and it's just one of those sets. The other thing I did, the power supply was 13.2 volts, as you know, and what I've done, and I don't often do alterations, is I've changed the resistor here, that's 302, I've changed it to 220 ohms from 150 ohms, and now we have the power supply at 13.8, which is where you'd expect it to be. Now most CB power supplies have got a preset there, so you can just trim it between the tolerance of the components. This doesn't, so I've done it that way. And the other thing I did was to change the 3 capacitors in the power supply, and I say we've brought this up from, what was it, 2.5 watts? We brought it up to 3.4, so we've gained a bit more out of it. It's certainly at the lower limit. I'm sure it'll work fine on the air, and it's had some inexpert work in the past. There's some wiring around the MC3357 where tracks have lifted because, you know, not to remove the part properly. So there we are. At the end of the day, it's 38 years old, and the sensitivity with 0.3 of a microvolt, 0.25, 0.2, 0.15. It's about 0.25 is usable, so it's better than a lot of sets. It's certainly better than the well thought of Unidens as far as sensitivity goes. 10 decibel attenuator switch brings it down to 400 milliwatts exactly. And I'll pop it together. We've had the lids through the dishwasher, had the knobs through the dishwasher, and I'll just shove it on channel 19. We'll have a quick flick round and see if there's anybody out there we can hear, and then later on we'll do an on-the-air test, no doubt with Mr. Chippy. So there we have it, the Realistic Navaho TRC3000, the only realistic base station that ever was made for the UK market. Nice, Roger. Well, there they are as ever, talking on 19, spoiling it for others. Right, we'll do an on-the-air test. Thank you for watching.